Hey, James. Good to see you.
I labelled it for Nord.
Hi everyone, thanks for coming. I want to start off by saying thanks to James. James is the, where are you, James? Hi. James has been organising the Clojure meetup for years. He's the only reason it's like it is tonight, the full house. So I'm really excited about our first speaker. I chose this image. I wanted to represent production systems. I put this one up here because it doesn't quite reflect it because it's not currently on fire. At Zendesk, we sometimes have issues where Uber can't do customer support anymore. And it's really bad. And people come looking for Australians to shout out. And so we like to test stuff before it goes out into production.
How do you know they're looking if you can't do customer support?
Say it again.
How do you know they're looking if you can't do customer support?
Oh no, because their executives come looking. Yeah.
Okay.
So it's a problem, and so we like to test stuff, including like having a QA process to test things while they're in production or when they're in staging, like to do integration testings. Like when many systems come together, and we have many systems, hundreds of thousands of lines of code, hundreds of engineers, etc. But it's really boring. No one likes to do it. Has anyone ever manually tested things, like in a browser with a mouse? Did you feel like this or look like this? I look like that one. It's really bad, and like the obvious like other parts for a business, right? Because it's humans. Humans are bad. But also automating that process can be really boring too. Like writing scripts for browser specs. Hands up, who's written things with like Capybara and Selenium and like even in the cloud on like Source Labs and like that stuff, and tried to debug it. And found that it takes forever, and that it's flaky and it breaks for no reason, and you just don't want to do it, right? You just want to pay someone else to do it, put them in a corner and hope they do it okay, and like not talk to them, right? It's because it's really repetitive. Yeah, that. So either stuff doesn't, like either you have to hire bad people or pay shitloads of money for good people, or your stuff doesn't get tested properly, and then Uber executives come. But to me, when programming is boring, it's a sign that we just need to introduce a little bit more automation. These are some examples, just historical examples of like why garbage collectors are written, or like why we have automatic linters for style guides. Like any of these things, right? Sometimes when you're programming and you're like, I'm so bored, you have this like feeling of ennui of like, I don't want to work in this job anymore. Sometimes it's like a red flag that actually it's like a more interesting problem, which is how do we automate this? So if we were trying to automate integration testers, like the people writing the test code, not the people like manually clicking through stuff, how would we do it? Well, what are they doing, right? So it's like these 4 basic steps. They look at what's currently going on, like the to-do list has no items in it. Then they pick something to do, all the possible things they could do. Like in that instance, it might be add a to-do to the to-do list, right? They get the computer to do it. You know, by typing in like find element, fill in form, click add button, that kind of stuff. And then afterwards they make some assertions. They say like, has that list now been populated with one to-do item? And then they repeat. They keep adding more and more specs in that same structure. Huh. That's fine. I guess I thought of this while I was writing the slides, and I was like, wouldn't it be great if there's like a visual way of representing an example rather than describing it to the audience? But how do they know what actions they can do and like what things should look like after they've done them, etc., etc. It's not magic. It's a mental model. I really love Google Images because you find etc. But a model, simplified version of the real world. And like the key is it needs to be a simplification. Like you can't have the whole system specified there because it's ridiculous. And the only person who can like do that in their head is maybe like John Carmack or something like that. But where does the model come from? Like we have this mental model, simplified representation of our systems or they're in production. The model is like, well, a large part of it is natural language processing by a human, right? it's going around and asking people, how does this work? Like, what happens when I do this? It's partly just like the experience of using the software. Sometimes it's reading the source code, or like reading documentation around business rules and processes. And then sometimes there's like what you can think of as common sense, like being able to read a label on a button and like apply physical metaphors. So the problem in this situation is that the model is implicit. It's not encoded anywhere explicitly or declaratively. So like you can read through a test and see that the person who wrote those tests had a model in their head. And often it's a good model of the system. So an example of where there's like an implicit model is with a style guide for a company. Like if you guys have a style guide for your code base, right? And it might be encoded as a markdown document. And in this case, there are plenty of places that just follow community style guides like this one. But there are ways of encoding it in a machine readable format, and you can get lots of useful things that come out of that, like automatic linting and things that reject your pull requests if you don't have the right amount of etc. So ideally, we want something like that who's able to tell us what a system is doing, or at least like what a simplified version of the system is doing, so that we can then generate useful things like specs for our tests, specs for our system. So what would be really nice is just to end up with a data structure that was a series of user actions. So if you think about it in terms of the to-do list, adding a to-do in call hello, mark here is done. Just like a really simple user journey. And you can imagine at each step of the way you'd want to be asserting like what things should look like. But initially you just want to generate like a valid sequence of user steps. And then you also want to know how to do each of these things in the system that you're interacting with. So at some point you need to interact with the real system, like the to-do list in the browser. This thing needs to know about how to actually click buttons that add the to-do and like fill in forms, stuff like that. They basically need to map these actions of, say, adding a to-do to real-world interactions, DOM events or API calls or whatever, right? Even method calls. And then they also need to like know how the state should be changing. Yep, and then similarly, like being able to assert things in the real world. So it's basically like you can imagine you have this model that like represents the system. You're like watching for changes that people are supposedly making to this model, and then you're comparing that to the real world. And any place where there's deviation, that's a problem. Zendesk, like part of Zendesk looks like this. It's like a help desk. You reply to people who have problems. We have apps that let you customize it. That's one of the things we do in Melbourne. It's a pretty simple setup. It's like a user can create an app that's specific to their system. And then they can install it. And when they install it, they're creating an installation object. One to many. So in the like messy real world terms, the way you write an app is by like writing a bunch of JavaScript and HTML and CSS, and then configuration is JSON files, zipping it up, uploading it, either through web interface or REST API. And then for installing it, once again, either API or through the web interface, right? So it's an example, Jody. Just like with the to-do one, but this one with creating and installing apps, like that. It's the kind of thing that if we hired someone to write tests for us, they would write to make sure that the process of creating and installing apps works on staging and production. And they would take something like this and they would convert it into a spec. So if we're going to have this model, what does it need to contain to give us what we want? Well, when is it possible to do an action? You can't delete a to-do unless there's a to-do in the to-do list, right? For each possible action, there needs to be something, checks the state, and says, is it even possible to do this thing? Because when you sit down and you want to test that the system's working, you look at how it is at the moment. Say it's in a web browser, you look at the state of the app. You say, what are the possible things that could happen here? Which of these am I going to try and do to test out this app? And the way you work that out is by knowing that. Then as a transform state, like that's a very simple example. Yes, installations should go up by 1. That'd be an extremely simple model. In a more complex model, we would actually say that there's a set of installations, there's one element, and the element has these details, which would ideally match what is in your model and in the real world system. Yeah, then once again, like, how does it interact with the real world? And then at the bottom, what kind of data are we working with? So like in the case of creating an app, you can say, all right, there's an action to create an app, but there's like a whole bunch of like different ways that you can create the app and like, configure it, blah, 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 blah. Same way if it's like create a customer record via the API, you need to like work out what fields to put when you go to create the customer, right? And there's like a variety of different ways you can do that, and only some of them are valid. So you need to be able to generate valid data. To drill down into create one, you can always create an app in Zendesk. Like in this simplified model, just like, that's fine, it just like always returns true. Transform adds a create app to the list. To perform it, it does all this messy real world stuff, ends up uploading stuff. This is what that description looks like in this Clojure map. So I've given it a name, just for my sanity. Possibility check always returns true. Generator uses this thing appgen, which I'll talk about very soon. Perform does the messy business of actually uploading it. The transform will say, all right, grab the state, look at the WhatsApp key apps, and then conjure app to it. The bit at the end here, the add ID to the state, is because when you actually interact with the real world and you create the app, you get back an ID, right? Which
You shouldn't, not if you're doing idempotent creates. The client should generate the ID and declare it to the server.
But like if they're UUIDs, that you mean we're fine?
That is
Okay, yeah.
a way of doing it, yes.
Totally. But I guess with like a lot of legacy systems, you have like only constraints, and one of them, like with R1, and I say with a lot of REST APIs, is that when you create an object, you post to it, and you get back a generated ID. Is that right? In a lot of systems?
Yeah.
Okay. So that's why at the end it says add ID to the state. So the next action that comes along, the one that's actually going to install that app, has an ID, so it knows what to refer to when it posts to installation, to create the installation. Here's a slightly more complicated example of the install app one. You can see in the possibility check now, it's not always the case that you can install an app. There needs to be an app existing, right? Just like you can't delete a to-do without there being a to-do. So like just a pure function that takes in the state of the model, and it says whether or not you're allowed to create it. Generator, I'll talk about that in a second again. But it's basically saying the gen elements bit and then the app state is kind of like passing through one of the apps for it to install. Thing creator shouldn't actually be there. I've removed that since. Shouldn't be there. Perform. Once again, like actually just hits the API. That install app function is one that will do the side effect of posting to the API, grabbing back the ID and chucking it into the state. And then similarly, the transform function is super simple. It's really just adding to this, the simplified model of the state. It's adding in this new installation. So how do we generate the test data? Like how are we generating these apps and installations? I'm using this library test.check, property-based. I can see just read what's on the slide. But as an example, here's something that tests that all vectors of integers, when sorted, or sort should be idempotent when you pass in any vector of integers, like no matter the size. And then it'll check it 100 times. It's not quite randomly generating. It's like starting out with very small vectors of integers, and then like making it increasingly, I guess, like large numbers, negative numbers, then like large vector sizes, etc. And it'll fail if for any of those vectors of integers this property doesn't hold true. Here's an example of it failing. It's because in this one it's saying the property that says for all vectors of integers, none of them should contain the number 42. So obviously at some point it's going to fail, right? The point at which it fails is here on fail. That's the example it failed on, as it was as it was generating these examples. But then it goes through a process of shrinking, where it'll keep trying to simplify the case on which it failed until it gets down to a minimal failing test case. In this case, the vector of 42. You can imagine being handed that and told that it's not working, and then being handed that and told that it's not working. Which one's easier, right? And the nice thing is, if you write your generators in the way that they've written theirs for these simple data structures, if you write your generators for more complex data structures, you get this stuff free, the shrinking, etc. So this is an example of how we're using their built-in ones. Is that this is a very basic level, an app can have a locale based on where the people are using it. And this gen elements is saying, I am a generator that's going to return a single element that's randomly selected from this collection that you pass in. A more complicated one, I'm using this test.chuck, which is a utility library. It has this very useful macro called for. I don't want to explain all this stuff, but they're basically things that apps can depend on. So like if you're going to install an app, it can like require all these different things that could also exist in Zendesk, and it'll go and create them. And so like as part of when you're creating an app, you can specify if it requires any of these things, and that's where these get generated. And you can see that it's doing these things in parallel because they don't need to know about each other. But then ticket fields, data from ticket fields is getting passed through the triggers generator. This is something that's like hard to do just using the kind of vanilla test.check generators. At least like once you do a few steps of that, it becomes really hard to read. And then there's also the when condition, which says I only want ones that don't have IDs that are the same, because it's just like another restriction on what is out of data. This becomes something like that. This macro expansion thing, by the way, is a built-in feature of Cursive, the IDE I've been using for Clojure for quite a while. And you can see that there are things like that previous example gets transformed into this. It's using things like bind and fmap and such that is like the when clause you saw before. Fmap is like a thing that'll like transform what you give it into this thing here, and then bind is like, all right, when I get something from another generator, pass it through this generator. Like the point is that it's like a lot harder to read. It feels a lot less declarative to me, at least. That's the library I was using. It's nice. The other thing they give you is generating strings from regex, which is really nice. And they're not brute forcing it. It's not like they're just like trying every possible string and seeing whether or not the matches it. So it's kind of efficient, actually. And then there's also this other library, Herbert, which is like a schema library, but the guy also wrote this way of taking your schema and making generators from it. So you can see in this example, I have this thing called parameters. I'm saying it's a vector. Parameters are a vector of maps. Maps, the type is always text. Name can be any non-empty string. Required, secure, either true or false. Default, non-empty string. So like it's a lot more declarative, but it's very limited. I ran into some limitations, and like I didn't know how to fix them because I don't know enough about combinators and monads and mathematics. And it's one of the first times. Yeah, right. But it was really cool. It was like it's not often that I like run into a limitation in the piece of software I'm using. And I'm like, oh man, I wish I had discrete maths, more discrete math. So it was kind of like a nice.
So what were the limitations?
Like even just like having conditionals. Like for example, in this one, if you wanted it so that required and secure were always the same, or if you wanted like default to not be there if required was true, something like that, you can't do that with Herbert. You'd need to employ something like test.chuck. So that's what the very top level app generator looks like. It's complex. It's composed of lots of different sub generators. But it's great because it like completely explores the space of valid apps in a way that the human probably wouldn't. It's going to find weird exceptions that humans like haven't found. When I used it to test one of our APIs, I let it randomly generate HTTP headers, and instead of finding a bug in our app or in Rails, it found it in rack. Because it just wasn't expecting this bizarre sequence of strings in one of the headers. So we have like this map of actions, and then we also have like the data that's getting generated so that we can do things with it. I'm not proud of this, and I don't think you should try and read it or understand it because I want to get rid of it as soon as I have time.
Else it will exist forever.
Exactly, yeah. It gets transformed into this thing. And I think I learned my lesson because that thing there is a macro that gets turned down into test.check functions. And I was writing a macro that would take code in and pass it through the other macro, and it's not hygienic in the technical sense, and it's just like it's awful. But at the same time, like it works fine. Until it breaks, I'll probably keep it like that, or until Until I guess I really want other people.
Until I leave my job.
Yeah. Exactly. Oh yeah, so that's the thing I showed you before, the map of actions, right? So I have this journey generator now, which comes from here. That thing down the bottom, the macro. Sample is a function that will show. Sorry, it'll keep giving you back like randomly generated things from the generator. Not random, things that are generated from the generator. In this case, I just grabbed the first one, so the first journey it generates. Journey, by the way, is just a sequence of like actions and then things that the actions are operating on. So you can kind of see that. So journey, when you grab the first thing from the journey, it's just a step. Because the journey is a sequence of steps. From the step, it's just a pair of an action and the thing that the action uses. There's got to be a better word for it, but like if it's like creating an app, it needs an app. Creating installation, it needs an installation. If you print out the keys of the action, you can see it's just that thing I showed you before. This guy. Ooh. This guy. And print out the app, it's just, that's some of the stuff I was generating before in that complex app generator. So, Clojure.test. Clojure.test integration with test.check. So I can just say def spec, journeys can be completed, pass through like a number of journeys that I care about. One of the nice things about this is that if you want to more fully explore the space of what your app can do, you just kind of like need to scale up computing power and like put a big number in there, or like parallelize it. This thing's saying for all the journeys that can be generated, just make sure it can be completed. As in like walk through, take each of these steps along the way, just like double check that things are looking like they should look like. If you get to the end, nothing's thrown an exception, nothing looks wrong, then you've just done your test. As an example, I like to, everyone see that's just like a list of all the names of all the steps. Yeah, so you know, create app, install app, create app, install app. The one that we have running on Jenkins is more complicated because it has two different actions. Oh yeah, sorry, the journey can be completed bit. It's kind of critical. First of all, it destroys all the apps just to make sure that we're in a pretty clean state, at least for the sake of our model, right? Because obviously, like the servers that the app is running on aren't in a clean state, and like we don't know what the clock is currently at, or like if someone's like created another user somewhere on the account. But for intents and purposes, destroying all apps will get us back to a clean state. And then it's just a reduction. So it's basically, it's like, you can imagine it's iterating over all of the steps in the journey, performing them, and then passing them through to the next action, or passing the state that comes back from that to the next action. So like, remember how I said before, yeah?
Does your journey generator guarantee that the actions that it generates are a sequence of valid actions that make in that order? Or is it broader that you just you fire random actions and...
Yeah, that's a great question. So the possibility check is able to tell you whether or not it's a valid sequence of actions. As long as your data is being generated correctly, like you're generating, say, a valid app, valid installation, you'll know that like, say you start out with like an initial state of nothing, just like an empty map. You say, all right, is it possible to create an app? Well, the answer is yes, because it doesn't even check the state, right? And then,
so you have a sequence of actions that generate and save.
Say it again, sorry.
I guess the point I'm pushing towards is it feels a lot like a finite state machine to me. Like,
oh, it totally is. I'll show you an image I generated.
oh, cool. That was going to be my question.
Yeah, totally. So if you just look at the possibility check, the generator, the transform, those are just, they're pure functions, right? And from it you can generate a state machine.
You derive a state machine rather than declaring one and what. Because you could almost generate this from a state machine if you declare a state machine instead.
Yeah, well the thing is that this does declare a state machine, and that all you need for it is like knowing what actions can go from what thing to, like what actions can be performed in any state, and then also how the state will change given that action. So if I skip forward, actually no, I'll show you later the state machine that gets generated from it actually.
So won't your journey generator generate a list of actions, some of which may not be able to be performed, but the action itself, like when you try to perform it, it checks and then it notices that it's not valid to be performed?
No, so before it even starts like trying to do those things in the real world, it'll
Yeah.
generate a fully valid journey.
Okay.
And the way it does that is by checking that possibility check thing. So it's not like it'll try and like install an app without one existing and then hit the API and find out that, oh, sorry, that can't work, I'll try something else. Beforehand, using,
So you have to declare what
So that
what actions are possible in what states?
exactly. Well, yeah, that possibility check does exactly what you described. But
okay, so the transform is modifying something that future possibility checks check against.
exactly. Yeah, totally.
Okay.
So we started with empty map. The only possible thing we can do of all the actions we've specified is create an app. And when we do, when we go to the next state through the transform, we add in an app. And now we look through the map of actions. We run this possibility check on this new state, which just contains one app, the app we've just created in the last step. And then now we can say that, oh, install app is actually a valid action because the possibility check returns true for it. Because the possibility check for the install the app is just, are there apps that I can install?
So where are you making assertions, or where are you defining the properties that you want to enforce?
Yeah, good question. So the this state that we keep, where we've conged on an app, is actually an app, like it's the full data structure that contains all the information about the app that we would want asserted, such like its name, right?
Yeah.
So that app is, like, corresponds to the one that Generative generates, and it has, say, a name. And so we wanted to check that when it got created, it has that name. You know? You know what I mean? So we would, like, after we perform the action, I can show you, sorry. After we, there's assert world state is correct,
Yeah.
given the expected state. So the expected state will have, say, it'll just be like, after create app, it'll just be a set of apps, and the app will say have a name and like a whole bunch of other stuff. And then the assert world state can just go through and say, all right, so there should be one app, and it should have a name like this. And the way it does that is actually by hitting the API. So you'll be testing out, or in the case of the browser example, like browsing to the page with apps and like doing a count of the list or something like that. You know what I mean?
Assert world state is correct is checking whether the real world, such as it is, matches the model that this thing is building as it goes.
Yeah, exactly. Yeah.
So just one thing, if I were doing this by hand, I would say the state after has to have one more app, and one app has to have this name that I just created, and only one app has to have this name. Imagine
Yeah.
that this is how I do it by hand.
Yeah.
So how does the system get to there from your transform state?
Yeah, totally. So after it actually goes and does the thing, like creates the app, then it does this assert world state to create. That needs a thing that tells it where do I look to find apps.
Right.
So then it can go and get the list of apps and like compare the state that it has, which should be a model of the state that the API is exposing. And the model says, all right, there's one app and it has a name X. And then it'll do a GET request, get back all the apps, be able to see that it's a list, and that it's length 1, and that one of them has a name X.
But what I'm asking is, what is the kind of mental state, as you mentioned before, the kind of model that allows you to go from the transform state, it would be a conj, right?
Yeah.
To the one where I've actually had a corner case where another app changed name. So I have to check not only that there's one more, but also there's only one of this name.
Oh, because it's able to see that there's a set of apps and only one of them has that name. So that state is there in that expected new state thing there. So the state, like it says, like there are apps. It's a set. There's only one of them, and it has this name. So then when it gets back all the apps, if there's two, or if there's two with the same name or anything like that, then it breaks. It fails the assertion. Oh, am I misunderstanding your question?
Yeah, but you have had to write that by hand. Was it generated? Is my
Oh, yeah,
question.
yeah, exactly. So the bit that does the assertion will depend on how you're interacting with the system. So in the case of a browser, it'll actually be, like it'll need to know where in the DOM the app lives. In the case of the API, it'll need to know the endpoint where it can check apps. You see what I mean?
So,
As in, like, it needs to be specified on top of that.
Yep.
Like it doesn't fully flow out of that map before with the form. Like at the moment, like the big thing that we're getting from this is just like we're not getting any exceptions. Like we're able to do these like 10 things in a row, and like the API isn't complaining at all, not giving back any error calls, or the browser isn't throwing exceptions. And then I'm doing very, very basic assertions on saying that I go through the list of all the apps and all the installations and see if they match exactly. So this assert world state I put up on the slide, but all it does is say, take the state, look at the apps and the installations in the state, then hit the API, make sure they match exactly. It's a very short function.
So this whole testing framework, really all it's doing, well, what it's doing for you, that you don't have to specify yourself manually, is generating journeys, generating test data that'll be put into certain fields and stuff.
Mm-hmm.
What
Yeah.
else?
Yeah, exactly.
Or is there
But as
anything
far as I
else?
can work, like that's what testing is, right? that
Well-
fully covers everything that a tester would do, I think.
No, but well,
The assertions seem
when
to
I'm
mean-
writing
the
capybara
assertions seem to mean
tests,
something.
the time-consuming part is coming up with, well, writing the assertions and writing the code that interopts with the page.
Yeah.
And with what you've got, you still need to do both those things, right?
Yeah, totally. Yeah.
But the difference is that a lot of systems that do testing tend to test the delta is correct. So they'll like have a state, make a change, check that the system changed correctly. Whereas this is kind of a little bit more functional in the extent that like you kind of just say, well, like something happens, I'm in a new state, and I'm going to fully check kind of everything in my old state, everything in my new state, and make sure they're correct. So for example, you only have one simple assert world state is correct, that it's like a couple of lines, and that covers all journeys. So instead of having like a whole barrage of like little assertions mixed up through many, many tests, they're all concentrated in one place, which is this assert world state is correct. And in this case, it's simple.
Yeah, you're right. No, that's exactly right.
So they're more like invariants of the system rather than
Yeah.
specific delta.
That's the
assertions.
word.
Yeah,
looking for.
exactly.
Yeah.
In fact, there's a paper that will come up on like a slide and it says the word invariance, and you'll feel smart.
Yeah. You are. Just one last question, sorry,
Yeah.
about that slide.
And one for me after that, please.
Yeah. Like, so when you're applying this like in the real world,
Yep.
does assert world state is correct kind of have backdoor access to
No.
the store?
Just uses a public interface. Yeah.
But so how's it, for example? Oh, so in this case, it's only tested for one user, like it's not.
Oh yeah, exactly. Yeah.
So have you used it in other situations where, because like a big problem that I've found in testing is that you try to test something in a public API and there's some state change that really needs to happen, but is private. So then you end up having these like wacky private backdoors so that your testing thing can check.
Yeah,
I don't know.
yeah.
I was just wondering if you came up against that and if you had
Yeah,
a
so
solution.
that's a case where I wish that Zendesk was older than like 2007 or something.
Yeah.
You know, like because it would be nice to test against like some uglier APIs that like didn't expose that kind of, or didn't let you modify the state of the system as you want. What? Whoa! No, hang on. So that, because you probably didn't write those ones that needed you to do the wacky private backdoor, right?
Well, not in that case.
Yeah. Right.
But I don't think there are always situations where state you care about is also public.
Say it again. Sorry.
I don't think there's in every situation
right, okay,
state you
yeah.
care about is public.
Totally. So this is like testing it from the perspective of a consumer of the API. So we want to make sure that our public REST API works.
Yeah.
Can I just ask about the possibility check?
Yeah.
So it rules out journeys that you as a human have ruled out. But isn't that wrong? Because you wanted to test things and find bugs in
That's a great
the
point.
edges, right?
Yeah. So yeah, ideally, and at some point in the future, I'd like it to try things that are not valid, and if they work,
Yes.
fail. Right? That'd be great. Yeah. So it would just be a matter of writing different generators that generate invalid data. Oh, and sorry, and also like I guess like relaxing possibility checks and stuff like that. Yeah, you're right. So this is useful. It's already called bugs. And it was super simple to set up. It's really like on Jenkins, it's just like line test. So like one nice thing that has come out of this is that we've been changing the way some of these things work, like with that ticker field stuff. And this new rule came in that if you're going to install an app twice, it can't depend on ticker fields. Yeah, exactly. It can't depend on ticket fields because there might be a clash between some of the ticket fields or something like that. And so changing that was just in one place. Which is really nice, because you can imagine like the other way around would be that you'd have a bunch of specs that implicitly tested this or explicitly. And you'd have to go through and you'd have to check for that spec. Or like you'd run them all and you'd see the ones that failed, right? And then you fix the ones that failed. And the thing about them that made it fail is that they were, implicitly asserting this rule that you can install it twice no matter what. And you'd have to go through and change it in a whole bunch of places. In this case, I was able to just change it in one place in a map, and it felt good. So that yes at the end is a lot of bravado. Like given enough time, it'll like explore a huge a huge range of different state spaces, code paths, etc. But there's still a lot of value in like human intuition about which parts are most likely to break, and like critically which parts are more important. Like you want to test your like payment mechanism goes through correctly before you test that like your to-do list doesn't break when you add like 5,000 to-dos with the word J, right? There are some things that are more important. And I think, there we go. So it would be nice to be able to like specify somehow declaratively in this map that like the way the way the one action follows the next is based on some weighting. Whether it's just a simple number that tells you probability, or if it's based on the state of the current system. You can imagine feeding in user analytics to it. So you can see that 90% of people are like going through a particular path. It's really, really important to test that path well, right? You can just grab those numbers, feed it into it in real time, right?
What about regressions? Because I find that, in real world situations where you half your tests end up being regressions that you found either during development or even in production, and the tests that are, like the mindful tests at the beginning are only the other 50%. So you put it in here, do the tests that account for actual defects that you found and fixed.
Okay, as in like if you found a defect previously and it wasn't being called by the test, is it by your test, is that what you mean?
Yep.
Well, I guess it would either be two things, right? Either
so make sure that you hit the corner cases that have already tricked you, not theoretical corner cases.
Yeah, I see what you mean. But so there'd either be two reasons why I wasn't catching it. One is that your model wasn't close enough to the system. Like it needed to have more things in it, basically. Like it didn't specify, like it wasn't generating the kind of data that would trigger that bug. So either it's that, right? Or it didn't have enough time to run, and it was exploring a whole bunch of like random different things. And so I can see two ways to fix that. One would be to fix the specification in your model, and the other one would be to yeah, so have it run longer, but also do the you can pass in a seed. Like for example, you pass in a seed. You can make sure that like when it failed on a particular seed, it tries that every time. Or
your risk weighting idea.
Yeah, right. You're just the weight. Thank you. This guy's name is Alistair, by the way. It's a fine name. I just saved me as well.
Yeah. And also, Harvey, like I've noticed when using QuickCheck, often you rely less on like specific, like very specific regressions, and you'll often just like add a new property or something as opposed to like creating a specific test. So
you describe the situation that the regression broke rather than rather than the input data that broke your system.
Yeah, and that often works really well.
So you describe a new invariant.
Yeah.
Yeah. But I guess the problem is that you can't be guaranteed that it'll try that in the future. Do you know what I mean? Like even if it's described properly, you can't guarantee that. Like say you didn't run it for long enough, it might not try that combination.
With your weight system, it might help if you do something like make sure that you produce at least one that covers.
True. Yeah. Also throwing more computing power at it. Oh yeah. Yeah. So this is something I've only prototyped, and it's ugly, but it's a matter of changing the perform function. So I just started using the clj WebDriver library, having it perform for a browser in there, and just making sure that there's the initial state includes like the session, so the browser's actually running, and then like the model stays exactly the same. Because if you think about when we have a browser interface to our marketplace, right? Behind the scenes, it's using the REST API. They're both two interfaces to the same set of business rules and the data store, right? And so all you need to do is change the way that it actually performs these actions, like creating a new to-do, rather than creating an app, rather than hitting an API endpoint. You're actually like going through a sequence of steps in the browser, rather than doing a GET request to the app's endpoint and then like scanning through the list. You're actually scanning through a list of the DOM on a certain page. And it's just 2 extra functions to the map, or a different map, just like specifically for browser ones. Oh yeah, that's actually true. Oh yeah, so I started doing something else, which was like, it's nice, well it's not nice, but like this has been helpful in testing legacy systems. But what if you design your system like from the get-go to have the model shared between the application code and the test code? As in all those state transforms, instead of those using to like generate a valid user journey, I reuse those same state transforms to say what happens when I click add to do. It's conjing onto apps in the state, right? And one of the nice things that comes out of that is that it's able to scan through all the available actions and just like randomly do them all. And like it's set to the state. Well, actually, I guess the other system gets that too. But yeah, I got it for free with this one. I didn't have to like write anything extra. I didn't have to like specify anything extra in terms of like the generation or the or like the transforms or the I guess the only thing I had to add was like the random string bit. The rest of it I'll show you. So I have these components. They're like React components. I'm using a library called Rump, which is kind of like OM, but it doesn't try and manage the state for you. And then by specifying like the type of action that this thing, the type of entity that this action interacts with, and then how it gets transformed, a lot of stuff falls out of this. I'll show you. So I have this function, which is way too long, and you can see it just needs to be solved with polymorphism, right? But what it does is generates the event handler for a given component. So I have this thing component for, I say component for toggle to do complete, and I pass in the to do that we care about. So this whole component altogether represents a to do item on the page. Like after you've just added one, you now have this thing that represents a to do. There's a bunch of things you could, well, there's 2 things you could do to the to do. You could like toggle it as complete, or you could
word, mate.
That's pretty good. Or you could remove it. And both of those things are coming from that action map. So that the event handler knows that the way it should be transforming the state when you interact with this thing is that you should be like changing, like toggling the complete status, or like removing it from the list of the to-dos in the state. And the way that it knows what kind of event handler to set up is just that you say it's on click, or it's on change. And using the same thing is what lets me do this. So like saying that component there with the X, that action that the X represents, the action of removing the to-do, saying that it's like an on-click thing, means that when I go to test it, I just have to look at the action and see that it says on-click, and then look at the component where it is in the DOM, and then actually just click it. So you get a lot of, I guess the point is you get a lot of stuff for free, at least in this extremely simplified example, from writing your model like in a declarative way and sharing it between application code and the test code. But like I said, it's like a pretty trivial example, and like I have no idea how it would scale to more complex systems. But like I would love it if I was able to just have like one place that specified the business rules of the application and how it needs to be interacted with.
It's almost as if you have like a Roomba exploring your application. Right.
Yeah, like there's a reason we have a Roomba.
Yeah.
It's because vacuuming floors is boring.
Correct.
I mentioned that before. So the other thing that's nice about that map is that it's enough for me to generate a finite state machine. And the only way I can make it finite is by putting a limit on the number of to-dos you can add. Right.
It's a GPS trace of a Roomba.
It's funny. Oh yeah, I use that for that. Yeah, so something that gets me really excited is like when I think about how we're going to like eventually replace that thing that I did before for the testing with the API in the browser, for testing legacy systems, it would be really nice. I think it's feasible for it just to learn the rules of the program as much as it can, to learn the invariants through trial and error. So I was giving an interview to someone to come in and write test code for us, and the problem I gave him in the interview was like just giving him this system that was broken in a way. It was a legacy system, and just saying, can you figure out the rules of this without asking me any questions, and then write some test code to like assert invariants, right? And just like watching him do it was just a process of trial and error, and then like watching the way that the state changed based on his actions, and then like doing pattern matching on the data that he generated from that discovery process. So we already have things that are quite sophisticated in trying all the things that your system exposes, like fuzzing. Like it's typically a security thing. Like you're trying to find some mixture of data that will break your code or expose something or let you do something that you're not supposed to do. Just try every possible action, like blah blah blah. But if you're also like watching for how things are changing over time, it means you can start to infer the rules that drive those changes, those transform functions that we have in the map, right? So the only one that I can like if I was going to try and demo it, and if I was going to like write something that did this for an extremely basic example, I would do it for just like in the browser, you click a button, a number goes up, say it goes up by 5, right? Then you have a thing watching. You have a thing that knows like it's like able to scan the DOM, see there's a button, and that's something you can interact with, right? And it tries clicking on it, and then it's able to observe that the status change of the DOM, and then like maybe we try and parse the int, right? And see that it's a number, and it'd see that over time the state is transitioning in this way based on this action. Then you just take those inputs and outputs and chuck it into this library, genetic programming, which is like a pretty basic implementation of genetic programming, but it's for Clojure. And the idea is that you give it a set of inputs and a set of outputs, and you say, I have some function. Like, you don't know what it is, but I have some function that has these inputs and outputs. Can you just try like randomly generating code until it works? Except also like with having a fitness function that you get closer and closer to. So it's not just like brute forcing like random until something works. You're actually like slowly getting closer and closer towards it as the error goes down. So you can see in like the first example, or one of the first examples, it was just like way off, right? It was doing ridiculous stuff and it was like nowhere near what it was supposed to be. Over time, like the error goes down, it gets a bit closer until it arrives at what the solution is. So like, this would work for like pure functions, but it's simple, and I'm working on complex data structures. And that doesn't really mirror like much of what we do in the real world. So I think, yeah, if it's actually going to be useful, we'll need a human to constrain the search space somehow. To say like it's like this class of function, or like something about the data types, or even just like explore like this area a bit more. Just constrain the space as much as possible in order to get something useful out of it. And it doesn't need to infer all the rules of the system, but if it can like detect any invariants and then automatically test for those, it's a big win. Because like literally all you're doing is just like pointing it at it, maybe showing it some stuff, and then like walking away. And there's some prior research on this. This is from 2001. I recommend reading this paper. It's really interesting. The people did something like this for Java programs. So instead of doing it for a user interface, they were doing it for like the interface of the class. The big advantage was that they get to inspect the source code. But some of their techniques apply for even when it's completely black box. Yeah, so I basically see like two converging ways that we're going to get rid of people who are writing test code. One is like black box, one's white box. Black box is the one I just described to you. Yeah, this one, where it's just like trial and error, pattern matching, fire and forget. And then the one where we write our applications in a way that its behavior is declarative. And then from that, a whole bunch of nice stuff falls out, including the ability to automatically test all the possible different things that you could do with it, all the possible states it could be in. This makes me really happy. I just love showing this stuff because it's a Roomba. I'd like to be Kevin Costner in Waterworld because he's drying. I don't know. I want to dry things out. You can see some of the code online. Thanks for listening.
So is there a third model, which is if you've declared all the transformations or the transitions, you could have a random explorer that could generate all of the disallowed transitions that you don't get status 200s on and don't meet your state transformation invariance, whatever the test state should be, and then have a human tester essentially check the limits of where the random driver actually took the program. So I tried to start with an install, and the implementation candidate had a limit that says you need to create something before. So that path will be barred. All I need to do now is check that being barred from that path is valid. So I essentially can take an implementation back to the rules. Yeah, cool. So I'm actually focusing my tester on the boundaries of the system as implemented, that the explicit transition invariants haven't already codified. I'm reaching at something I've only just thought I was having good words for it. But.
So when you say like having someone at the boundary of the system, it's like they take the implementation as it currently is, and they try and find things that don't.
Yeah. So your possibility rule is essentially protecting your release candidate or your candidate system from tests. Now you can explicitly test that the system prevents those possibility rules from being broken because your test model prevents that. That possibility from even being run, unless you put some code to say, does it prevent this?
Right. Yep.
But you can have a random driver that just tries all of the valid steps because you've got all the state transitions and all the steps, and it can come back. I couldn't install them in create. Is that valid?
Cool. And ask it of the person who knows about the system.
Ask it of the person. Yeah. Essentially, the limit of this implementation is it cannot install before create. Is that right?
Yeah. Cool. Yeah, you're right. Yeah, it's going to be critical to have a human in there and having it interact with it, like an expert system.
Yeah,
I think that term is gone out of fashion, right? An expert system. Sorry, going.
It can come back to the developer then, and instead of having to do the sweep, you're now answering questions about is it right that the system stops here?
Yeah, no, you're exactly right. Yeah, just a daily email.
So you're generating the story, so you have the journeys or whatever through this quick check-like thing as well. So it does shrinking over them?
Yeah. Yeah, good question. I should have put that up there. That's a problem that I ran into, is that in those examples that were shrinking, it was working on arithmetic, right?
Yeah.
When you try and shrink like a very complicated data structure, and it takes literally seconds to create the example, it just doesn't work. And so I've had instances where it was running on Jenkins and something went wrong, and this is before I stopped it from trying to shrink.
Yeah.
And it would just ran for until I think it didn't crash the server, but maybe someone one of the operations guys saw it and was just like, what is this thing doing? He pulled the plug. But yeah, so I had to stop it from shrinking. So so in the case of the API, that's what happened, right? But I can imagine it being a lot better for in the browser when it would be much quicker.
Yeah. Also, I think that with shrinking complex data structures, one of the situations I was in, I had to write some reasonably sophisticated custom shrinkers to get nice shrinks out of stuff with really complex data.
Interesting. Do you think there's a way that the person writing the application could just for optimization purposes, specify a way in which to shrink things to try more stable functions?
Yeah, Quick Check has that feature. Maybe you just need to dig around in the test.check.
Yeah, cool. Yeah, read some more discrete math specifics as well.
Maybe not. Normally it's just stuff that makes sense. But normally it's like these fields normally don't matter, so just drop them immediately and
Wow, that's really useful. Thanks. Brendan?
Oh yeah, I was just wondering about the workflow of adding new features. Is it on the developer to try and work out new?
Well, in this case, it's on me.
Do you see dedicated people working on making the testing?
So it depends, I guess, if you're still doing the testing legacy systems thing, whether in the Blackbox style or the Greybox style, or if you're doing it where you have the shared model between application and test. In that case, it would just be a developer. In the other case, it might be you still have test engineers. Although I think places like Twitter and Facebook, they don't have test engineers, they just have engineers who solve problems.
Has this found any bugs?
Yeah, it did.
What were they?
Yeah. So we had it so that when it was deleting an app that required stuff. Remember how you could require all that random stuff that like had to be installed before the app was installed? When an app was being deleted, that stuff wasn't also getting deleted. So when it got to the so the idea is that like the app becomes tied to those things, like to a ticket field. When the app gets deleted or uninstalled, those things should go away.
Yeah.
And they weren't. And there was a bug. It was in production. It didn't affect anyone because it seems that no one was using the feature. It makes me pretty sad. But yeah, that's the bug it caught.
But had you written
That was
invariant for
found
that
by-
so why didn't
Say it again, sorry.
I said that's might be why they've not been using the feature. Because
Yeah.
somebody's cracked it
Yeah.
and they just kept away from it.
Yeah, maybe. Yeah.
That would have just been found by the way you wrote the assertion, right?
Yeah,
Like,
totally. Yeah.
It wasn't that the test suite had generated a novel set of a novel journey that could cause that
Well,
invariant to no longer hold.
What? So hang on. So like it did. Like there's a specific journey that causes that to happen,
Yeah.
and it was generated by the journey generator. And like sure, like a someone normally writing tests could have written a test for that, and it would have been like install like create an app, install it, then go to delete it or uninstall it, and then make sure that that app, which has ticket fields by the way, make sure that app when it gets deleted, those things go away too. So they would
Yeah.
have to manually write that spec, right?
But you had to think of that case to write
No.
the...
No, I didn't. So no, I promise I did. I promise.
There was code in there, right, that would have said these things need to be deleted if the app is deleted.
Oh, true. No,
Right.
you're right. So it wasn't.
Yeah.
So
So
it's
they
not like
need
I
to
thought of
think
that
of that
specific
case.
case. I really
They
just
had to
I just
think
thought
of
about the
the
way
area.
that the state should change, like based on actions. It's not like I was thinking of like like this bug might occur. I just like wanted the model to represent the system. Do you know what I mean?
Kind of.
Well, I guess like think about it this way, right? Like there's a good chance that we wouldn't have tested that piece of functionality like writing manual specs, or we might have not have tested it in the right way.
I don't think that's the case, because you thought of the invariant, right? And once you had the invariant, I imagine the test case, the journey that would trigger that is trivial, right?
So it's
Like
not so
I
much that
imagine
we
it would have just
specify the
been create an
invariant.
app, add a dependency, delete the app, right? Like,
So hang on, so it's not like we're specifying that invariant in particular, it's just like one of the things that happens when this thing happens. One of the things that happens when we delete an app is that these things go away.
That is specifying the invariant, isn't it?
Yeah. Yeah, but okay, yep, no, that's true. So we're,
so was it?
Yeah,
in a sense.
Maybe I'm
Yeah.
misunderstanding. Maybe what were? So I guess if the dependencies were modeled in your kind of in-memory model as children of the app, then deleting the app would delete the dependencies without having something specific for deleting the dependencies.
no, so it's not like there was something built in that it knew about dependencies. It's more, it really just knew that like on this action, like this state should be changed in this way. So it's true, like we had to like specifically think of that rule and encode it. I guess the difference is that it previously, with another way of writing these specs, like with just the standard way, it would, like that model would be, that model would be in someone's head, and then it gets encoded in those specs.
Yes.
And if that rule changes, someone's going to have to comb through the specs to make sure that now that rule has been reflected in those changes. Whereas in this one, it would really just be that the transform has changed, and that would like that'll change like all the testing that gets done across all the journeys that are affected by that state transform. Do you know what I mean? Like
It's not the transform that would be important to change. It would be wherever you have the assertion.
No, so that's the thing, right? It's the transform that changes, because the transform is the thing that says like given this action, like
Yeah.
this action has just happened, like delete an app. The state should change in this way. The way it should change is that the ticket fields are now gone, like the relevant ticket fields.
Right. Okay, so the transform changes the state, and then that state is checked to make sure that it matches with the state as viewed
Exactly.
from the real world.
But it's not like we had to write a special assertion for this case. It was just like that like really simple function that goes through and checks that our idea of the state matches the server's, just by doing a few GET requests.
Yeah, okay.
Yeah, no, but you're absolutely right. It could have been caught previously. It's just that there's still benefits to doing it this way in terms of maintainability.
Okay.
So you're saying your model of the system is explicit and in one place rather than you defining a model and then coming up with a bunch of assertions that are scattered around the place.
Exactly. Yeah. I mean, unfortunately, in the case of the legacy systems, you have a couple of models. Like one is the one that's encoded in application code. Another one's the one that you've created for this test stuff. But at least there aren't two, and one of them's in the head of the testers and encoded, as you said, in the specs.
Is it also not the case that with generative testing have far wider reach or possible implementations than what you could get through a test online?
Well, like I think the human could do any of those cases. It's just like there's a good chance they won't try as many. Yeah.
Yep.
So, one thing I've really noticed in test suites in the wild is that they have this very common pattern of like, hey, here's like a section which like sets up a bunch of shit, and then we do like something actually pretty small and trivial, check the delta, not the invariant, and then kind of tear it down again. And often almost every test looks somewhat like that. And if you're lucky, some of that setup and tear down is like somewhat abstracted. But I think that probably, at least for me, the thing that would be most beneficial in terms of maintainability is just not having that pattern, like having it handled kind of a more general way. So that basically kind of like in this case, the setup and tear down have sort of happened, sort of handled implicitly.
Yeah, it's true. So one thing Andy touches on that I didn't mention is that I'm way more likely to actually write this code to test it if it's written like this. Whereas if you got me to try and if my job was to write browser specs day by day, given some model of the system, I would quit. I would go elsewhere.
But
Do you know what I mean?
it seems to me that
This is a big deal. Because
if browser tests annoy me too, but it seems that you're still writing the part of the browser tests that annoys me, right? You still have to write the code that says, here's how you create a to-do, right? You need to insert a value into this field, and then you need to click on this button.
So the difference is I do it once.
I do it once too, kind of.
Well, so here's the
I
thing,
would
right?
still have a create to-do function, right?
Yeah.
That I then call from my other specs.
Right, and so for every spec that you write that involves creating the to-do, you now have to call that function, right?
Yeah, that's fine.
Okay, except that in this way, I don't have to write specs that then call those functions. I don't have to write like a different spec for each of these possible things.
So the journeys are generative, basically. That's the key value, isn't it? That
Exactly.
the number of the permutations of state transitions through that finite state machine, you can sort of explore that generatively rather than having to prescribe ones.
Yeah, absolutely.
Do you do any concurrent testing? And one other question is, do you have any actions that are asynchronous that you have to?
Yeah, I do.
Not load testing really, but with concurrency, do you ramp it up by a factor?
Yeah, so right now, no, but I think it would be pretty easy to do so. The only big thing would just be making sure that the parallel threads don't stamp on each other's toes. Say it again. Sorry?
So making sure they don't share a browser or a session.
Yeah, exactly. Yeah, or in our case, it would be like a Zendesk account. Just making sure that they have some blank status to play with. Sorry, what was your? It was a concurrency and then another one?
Do you have any actions that are asynchronous?
Oh yeah, we do. So like installing an app, it can depend on say 1,000 different things, and that can take a little while to install. So that's asynchronous. It passes back a job status, which then gets polled. The process of say creating an app is not just one API call. It's actually multiple, but it's just in a single function. Like that messiness is kept in one place. It's the perform part of the action map.
So you must have timeouts on your assertions.
Say it again.
You must have timeouts on your assertions in certain cases that you would say within 5 seconds I expect this to create.
Yeah, exactly. Yeah, that's right.
But that's just a failure state of the part of the journey. So if that happened, you would try and shrink it and you wouldn't be able to find where it failed.
Yeah, but you're exactly right. But like I said before, the shrinking just doesn't provide anything useful to me in this case because it's so the operation is so slow that it can't shrink enough. And also because I guess I hadn't written custom shrinkers, which I didn't know I could do. Yeah.
But I think that maybe also in this example, there is not a whole lot of ways different features could interact in subtle ways. Like some, but not a huge amount. I think that one of the, and to go to your point, Logan, I think that the real benefit would come in situations where, because what happens if you write a new property or you write a new kind of transition, then that can get tested in kind of combinatorially many different situations. So that's really good because it's kind of every time you add a new kind of branch, you get millions more possible tests. The icky thing with quick check is then making sure that those million possibilities have a better yield than just kind of following the intuition.
Right.
Yeah. And I think maybe something you mentioned at the start also, that might be good because it will try things that are kind of outside your frame. That could be well, that's stupid.
Yeah.
I didn't think of that not because it's hard, but because it's just not even the way I was thinking of it probably.
Yeah, that's true.
Okay.